All right, Chapter 6, Section 6.1, Energy and Energy Units. This is our chapter on thermochemistry. Introduction to Units. Energy or Introduction to Energy. I said that dramatically and I said it wrong. How about that? Energy is the capacity to do work or transfer heat. This section focuses on our mechanical energy, energy that is due to an object's motion, position, or both. We've got two major types of energy that we're going to be talking about, kinetic energy and potential energy. Kinetic energy is that energy of motion. Potential energy is related to position. Kinetic energy is equal to 1/2 times m times v squared. Okay. Now, our units for energy are joules. 1 joule is equal to 1 kilogram times meters squared times seconds squared. So the way that all kind of works out is there's actually a typo there, and that is meters squared per second squared. Okay. Now, if you remember our formula, 1/2 mass kilograms velocity squared. Velocity, and an example for units of velocity would be meters per second. So if you squared that, you'd have to square that, which would mean meters squared per second squared. Okay, the calorie, or cal, is another commonly used unit of energy. A calorie is the amount of energy needed to raise the temperature of exactly 1 gram of water by 1 degree Celsius. So 1 calorie is equal to 4.184 joules exactly. Now, here is kind of our comparison of potential energy and kinetic energy and how they kind of flow into one another. So right now we've got skateboarder with a mohawk. I'm going to draw a mohawk. Yeah. Our skateboarder, right here where he is not moving, or where they are not moving, they have a high amount of potential energy and a low amount of kinetic energy. As they begin going down this half pipe, their kinetic energy increases. As they reach the bottom of this half pipe, well, their potential energy is lower, their kinetic energy is higher. And they continue on as their kinetic energy and potential energies basically invert. Now, common units of energy, 1 joule, well, is 1 kilogram per meter squared per second squared. Now, remember this 1 cal is equal to 4.184 joules. 1 cal. There we go. There we go. Okay, now, practice problem. A pitcher throws a baseball with a mass of 5.13 ounces, or 0.145 kilojoules. Heck, I'm going to go ahead and write this. M is equal to 0.145 kilograms. At a velocity of 95 miles per hour, 42.5 meters per second. Using the correct SI units, calculate the kinetic energy of the baseball. KE is equal to 1/2 mv squared. Okay, what's our velocity? Well, our velocity in meters per second is 42.5. What's our mass? 0.145. So our KE, kinetic energy of this baseball while it's in motion, is equal to 1/2 times 0.145 times 42.5 squared. So we've plugged all that into the calculator. Well, 0.145 times 42.5 times 42.5, or squared. Divide that by 2, and I get 130.95. Well, heck, what are my units? Kilograms per meter squared per second squared. Or I could write that simply as 130, I'm going to convert this down to 3 significant figures, 131 joules. That's all there is to it, being able to bounce back and forth between units. I hope this is helpful. We'll see you in 6.2.